Welcome to clickmyproject.com. Let's discuss on the paper Improved Image Recovery from Compressed Data Contaminated with Impulse Noise. In this paper, we are going to present a new approach to improve CS recovery in the presence of impulsive noise. CS is nothing but compressed sensing. Compressed sensing is a new formation sampling theory for recurring, sparse or compressible data with much fewer measurements than those otherwise required by the Nyquist or Shannon counterpart. By using a robust cost function on the residuals, we are able to suppress large outliers in the measurement noise. This will result in an improved recovery because the regularization parameter is not influenced significantly by these outliers, meaning that the recovered signal is not being driven farther toward to zero. And we also showed that an iterative algorithm can be developed readily under the majorization minimization framework to utilize the power and computational efficiency of the existing CS solvers to obtain the solution of the new formulation. And most importantly, we have established a theoretical guarantee on the improvement of the upper bound of the recovery error. The proposed method can be used to improve further compressed sensing recovery upon an inspection of the residuals for impulsive noise. Now let's see the explanation for the data flow diagram. The first block is input image. Here we are going to consider MRI scan brain images. So the user has to select any one of the images from the folder. The next to this, contamination with impulse noise. We have to add noise to the given input image, and the impulse noise is random in nature. That means the distribution of noise is random in nature. And here we are giving the option to the user to change the noise density for taking various experimental results. Following this, the framework comes here, that is majorization and minimization framework. The main idea of this framework is to consider recursively a series of problems, that is, the upper bound of the original problem, such that those alternative problems are easier to solve and that the solution from these problems converge to the solution of the original problem. Following this block comes quadratic majorization. The Huber penalty function rho, it has a quadratic behavior for small residuals and a linear behavior for large residuals, and its curvature at any point should not exceed the curvature of a quadratic function. Next to this block is iteratively reweighted least square process. The proposed algorithm is also an optimization problem. That means whose convergence rate is largely dependent on which compressed sensing solver is used. Here we are more interested in the convergence rate of the outer loop, that is, how fast the sequence generated is converges to the global optimum in assuming that can be solved with high accuracy. That means the optimization is an iterative process. So each and every iteration the least square process is going on. At the final, we are able to recover the original image. This original image is fully free from the impulse noise, and we can estimate the quality measure for this recovered image. The quality measures are PSNR, peak signal to noise ratio. We can compare the PSNR of the given noisy image and the recovered image so that we can justify our result. Now let us see the execution of our proposed implementation. This is the main file you have to run. csmain.m. Guide window will be shown to you. So first you have to press the button select image. File dialog window will be shown to you. Under the images folder, select any one image. Now I am selecting the file named as 120. It will be displayed in the first access control. Then next press the button contamination. Image is now added with noise. Now press the button Show Projection. The compressed sensing projection matrix is displayed here. All the values are tabulated. Afterwards, press the button Reconstruction. So this process will take time for the recovery of the original image as it is. That means we have to remove all the noisy pixels from that. So each and every iteration, the quality measures such as PSNR is computed and is listed down here. At the first iteration, the PSNR value is 23.1829. During the second iteration, now it is still improved, 23.2532. So various iterations are going on here. The fourth iteration is completed now. The end of the fifth iteration. Now the reconstructed image is displayed here. Now compare the recovered image with that of the original image. Now it is coming closer to the original image. So we can achieve a better performance. And the execution time in seconds is displayed in this text box. You may see the quality analysis performance when you press this button. So this bar chart will give you analysis between the original image and the recovered image. The computed PSNR is increased here, and MSE value is as low as possible. Now see the time analysis graph for various images. I have computed the execution time in seconds and it will be plotted here. So the x-axis it represents the image index and the y-axis it represents the execution time in seconds. After seeing all the results what we have got in this implementation, we can come to a conclusion. Our system will give the best performance while the input image is contaminated with impulsive noise. This will be very much applicable in medical images. Thank you.